Hello, today we're going to try to understand what happens to a water level when a chunk of ice which is floating in this water melts. Let's read the question together. 100 centimeter cube chunk of ice is floating in water as shown in the figure. When the ice melts, by how many centimeter cubes will the level of water rise above the KL level? Takes the densities of ice and water to be 900 and 1000 kilograms per meter cube respectively. Okay, so before we start, let's identify what holds ice in water, right? Why it's not sinking. So let's draw the diagram again and identify the forces. So force that's pulling it down is its weight. Right, so weight of the ice is going to be mass of the ice, m sub ice, times g. And force that's pushing it up is going to be a buoyant force. So these forces are balancing each other, and that's why ice cube is floating. And also notice that not all of the ice is submerged. Some of the ice is sticking out above the water level. This will become important in a minute. But before we proceed, let's just refresh what the density means, and also let's avoid using units like cm cubed and switch to meter cubes. Okay, so density is nothing but mass per unit volume, right? So everything has a specific value of density. For example, in this case for water, it's 1000 kilograms per meter cube. For ice, 900 kilograms per meter cube. So, all materials have a different values of density. For example, mercury has 13.6 times 1000 kilograms per meter cube. Okay, how do we switch from centimeter cube to meter cube? Well, easy. We have 100 centimeter cubes, and we know 1 centimeter is 10 to the minus 2 meters. So we cube this, it's going to be 10 to the minus 6. We multiply by 100, and you have 10 to the minus 4 meter cubes. So 100 centimeter cube is 10 to the minus 4 meter cubes. Okay, now we can go ahead and proceed with our question. So as we mentioned, buoyant force has to be equal to the weight of the ice, right? So, well, G we know, G is equal to 10 meters per second square, but let's write down the equation for what's the mass of the ice. Mass of the ice from here is going to be density of the ice times volume of the ice, which is 900 times 10 to the minus 4, or 9 10 to the minus 2 kilograms. Okay, now we know the weight of the ice. And what is the buoyant force? Well, buoyant force, a force exerted by the liquid on a floating object, is going to be equal to density of the liquid times gravitational acceleration times volume that's submerged under the liquid, right? So it's a volume that's displacing the liquid. So in this case, it's this volume, or this shaded region. If the object was fully submerged in water, then it would have been equal to the water of the object. In this case, water volume of the object. In this case, it would have been volume of the ice. But here we have to be careful. Submerged volume is not necessarily the same as the volume of the ice, right? So setting this equation equal to weight, so buoyant force, which is rho liquid times G times volume submerged, is equals to mass of the ice, which is density of the ice times volume of the ice times G. We get that the submerged volume has to be equal to density of the ice. So we just G cancels out, and then we divide both sides by density of the water, and we have density of the ice divided by density of the water times volume of the ice. 900 divided by 1000 times 10 to the minus 4, which gives us 10 to the minus 5 meter cubes. So 9 10 to the minus 5 meter cubes is under the water, right? So ice, in other words, is displacing 9 10 to the minus 5 meter cubes, or if you will, 90 centimeter cube of water. So it's displacing that amount of water when it's submerged. Now, what happens when ice melts? So it fully turns into water. So what we're gonna do, we're gonna consider the case when all the ice, mass of the ice, goes into water, right? So it transforms into water. So we know that the mass of the ice is 9 10 to the minus 2 kg. So volume of the water that forms because ice melts is going to be equal to mass of the ice, or mass of the newly formed water, divided now, since it's water, density of the water. So you have 9 10 to the minus 2, that's how much ice became water, divide now it's a water, so we have to divide by density of the water, and we get 9 10 to the minus 5 meter cubes. So originally, when ice was floating, it was displacing 9 10 to the minus 5 meter cubes of water, right? But when it melted, it transformed into 9 10 to the minus 5 meter cubes of water. So overall, the level of the water does not change. I hope this is clear, and that's the answer to this question. Level of the water remains the same.